Let's have another example of traverse and lot data computation from field notes. And let's say this is from magnetic azimuth. So let's compute the traverse. Press 1, new traverse. Enter the north thing of station 1, let's say 20,123. East thing 20,052.60. Then 0 execute because this is a closed traverse. We enter the first azimuth from T sub 1 to T sub 2. Let's say 150 degrees 58 minutes 62.75. Then T sub 2 to T sub 3 212.0. You may press delete if there is a correction. 0.04. Then 77.16. Then from T sub 3 to T sub 1, let's say 05, 120.71. Then to close it, press 0. Then you have now the linear error of closure, relative error, and total distance. Press execute to coordinate. Then you have a tabulation of all the coordinates. Then the plotting of the traverse. Then you go back to your Big Shots main menu. You enter the lot data computation, you press 2. Let's say enter lot number 1. Then corner 1 is equivalent to traverse 1, so press 1, 0 distance. Then corner 2 is from traverse 2, let's say 88 degrees 29 minutes 19.81. Then from station 2, so you have the coordinates of corner 2. Then the bearing 1 to 2 northwest. Go to corner 3, 145 degrees 28 minutes 31.60 meters from station 3. So you now have the coordinates of corner 3. Then line 2 to 3 north 2460 east or 25. Then corner 4, say 304.29, 91.77, again from traverse 3. Then to close it, 0 execute. So you have now the area of 10,029.30 square meter. So you have this plotting, execute, then press 0 execute to close. If we want to overlay the plotting, press F6. So you will notice here that there is a rotation involved. So we have to compute the rotation. Press execute. What we have to do is to use setting to compute the azimuth in distances. Let's say press 3. Then let's say corner 1 versus corner 2. Station occupied. So you have now the azimuth of 142 degrees and 14 minutes. To get 1 to 3, press X theta. Then you have again the azimuth in distance of 182 degrees. Then press theta again for 1 to 4. And if you want to get 2 to 3, just press F1. Then X theta again for 2 to 4. F1 for 3 to 4. So you create a matrix of lines between the corners of the lot. If you want to go back to the station occupied, 0 execute. Now let's say side shot 6 versus side shot 7, and that is equivalent to corner 1 versus corner 2. So you have now the azimuth of 137. Then if we want the next 6 to 8, press X theta. 6 to 9, X theta again. Then F1 for 7 to 8, X theta again for 7 to 9. F1 for 89. So you tabulate all the results of the azimuth in distances, and you can get now the common difference. Let's say you use the negative sign to get the difference between the two bearings. Let's say 142.14 execute, 137.14. So you have 5 degrees. Then 182.06 minus 177.06 execute, 5 degrees again. So you go on with the other computed bearings so that you get now the common difference. So as we can see, we have a 5 degrees rotation. So we will apply now this rotation. So press 1, then 6 to rotate. Let's say the rotation to apply is 5.00. Now you can see that the azimuth has been rotated by 5 degrees. Then you have the plotting, the relative errors. Then it will recompute the new coordinates using the rotated values. Press execute. The next step is to rotate the side shots. So you press the arrow key here, then from side shot number 6, then the rotation is complete. Then you can see now that the two lots will overlay exactly the same because of the rotation. That's the example of common point computation and the rotation.